I'm so glad you found your way here tonight. Your brain has been working without pause, sorting, deciding, absorbing. And right now, it is beginning the quiet process of letting go. You'll discover what exhaustion is really doing inside your mind, and understand why rest is not weakness, but science. Welcome to Sleepy Mind Science. Wherever you are right now, perhaps lying in the dim quiet of your room, eyes heavy, thoughts still flickering from the day, allow yourself to simply be here. We'll journey through 100 psychology facts about the exhausted mind. From the invisible chemistry of fatigue, to the brain's hidden repair cycles, to the profound science of why your mind needs this moment. These quiet journeys through mind science build a sanctuary for tired souls everywhere. A gentle subscribe, like, or sharing your thoughts creates a pathway for more exhausted minds to discover this peaceful space. One sleepy soul at a time. Your presence here means more than you know. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. The human brain never truly stops working. Even right now, as you lie still, your brain is actively processing signals from your body, managing your heartbeat, filtering background sounds, and quietly beginning to sort through the events of your day. What we call mental exhaustion is not the absence of activity, it is the accumulation of it. Neuroscientists describe the exhausted brain not as a machine that has run out of fuel, but as a system that has accumulated too much. Too many decisions, too many unresolved signals, too much unprocessed emotion. Tonight, as you listen, your brain is already beginning to unwind that accumulation. The science of exhaustion begins. Simply, here, the brain accounts for only about 2% of your body weight, yet it consumes roughly 20% of the energy your body produces each day. This disproportionate energy demand makes the brain uniquely vulnerable to fatigue. Unlike muscles, which signal tiredness through physical sensation, the brain signals exhaustion through subtler means: slowed thinking, reduced emotional tolerance, difficulty concentrating. When you feel mentally drained, your brain is communicating something precise and measurable. Its energy balance has shifted, and restoration is needed. The feeling of not being able to think clearly at the end of a long day is not imagined. It is biological, real, and deeply understood by science. There is a chemical called adenosine that plays a central role in mental fatigue. Throughout the day, as your brain works, adenosine gradually accumulates in the spaces between neurons. The more it builds, the stronger the sensation of tiredness becomes. Adenosine essentially acts as the brain's internal clock for sleep need, a biological pressure that rises with every waking hour and subsides during rest. Caffeine works by blocking adenosine receptors temporarily, which is why it reduces the feeling of tiredness without actually resolving the underlying need for sleep. When the caffeine clears, The adenosine that was waiting rushes back. The tiredness returns, often with greater force. The glymphatic system is one of the most meaningful discoveries in neuroscience in recent decades. It is a network of pathways that runs alongside the brain's blood vessels, and its primary function is to clear metabolic waste from brain tissue during waking hours. This system operates at a reduced capacity during sleep, particularly during the deeper stages. It becomes dramatically more active. Research suggests up to 10 times more active than during wakefulness. One of the substances it clears most efficiently is beta amyloid, a protein associated with cognitive decline. Your brain is not simply resting when you sleep. It is being cleaned. Mental fatigue may be, in part, a chemical signal from the brain itself. Emerging research suggests that sustained cognitive effort can lead to a gradual buildup of certain metabolites in the prefrontal cortex, the region governing decisions and self-regulation. When this buildup reaches a threshold, the prefrontal cortex begins to signal for disengagement. Researchers measuring these changes have found that a day of demanding mental work produces real comfort, measurable shifts in brain chemistry, not imaginary ones. What you experience as mental tiredness may be your brain's most sophisticated region, quietly communicating something precise. It has given enough for today. The prefrontal cortex is often considered the seat of what makes us distinctly human. Planning for the future, weighing consequences, managing impulses, feeling empathy. It is also the region most sensitive to the effects of mental exhaustion. Studies using neuroimaging have shown that when participants perform cognitively demanding tasks over extended periods, activity in the prefrontal cortex begins to decline in efficiency. Decisions become less nuanced. Emotional reactions become harder to regulate. This is not a failure of character or willpower. It is neurological. The brain under exhaustion is a brain with reduced resources in its most complex circuits. Decision fatigue is a well-documented phenomenon in cognitive psychology. Each decision a person makes, regardless of its importance, draws on the same finite pool of mental resources. Over the course of a day, as small choices accumulate, the quality and complexity of subsequent decisions tends to decrease. Research examining judicial decisions found that favorable rulings were notably more common at the beginning of the day and directly after breaks, declining as the session progressed. The mind, by afternoon, has already navigated countless small crossroads, each one leaving a faint trace. The weight of those choices is invisible but real. Tonight, you are relieved of all of them. The amygdala, the brain region most associated with emotional processing, becomes more reactive under conditions of sleep deprivation and mental exhaustion. Neuroimaging studies have shown that in sleep-deprived individuals, the amygdala's response to emotionally negative stimuli can increase by up to 60% compared to those who are well rested. Simultaneously, the connection between the amygdala and the prefrontal cortex, the pathway that allows rational thought to moderate emotional reaction, becomes less efficient. This is why exhaustion can make small frustrations feel overwhelming, why tired minds are more prone to anxiety, and why rest is not merely a comfort but a neurological necessity for emotional balance. Sleep deprivation, even partial, has measurable effects on memory consolidation. During sleep, the brain replays and reinforces the experiences of the day, a process called memory consolidation, moving information from short-term storage in the hippocampus into longer-term neural networks. When sleep is cut short or disrupted, this process is interrupted. The information captured during the day has less time to be properly encoded. Research has shown that people who sleep after learning new information retain it far more reliably than those who remain awake. Sleep, in this sense, is not the absence of learning. It is where learning completes itself. Cognitive performance and mental exhaustion are closely linked to circadian rhythms, the approximately 24-hour biological cycles that regulate wakefulness, body temperature, hormone release, and dozens of other physiological processes. The master clock governing circadian rhythms is a small cluster of neurons in the hypothalamus called the suprachiasmatic nucleus. It responds primarily to light, particularly blue wavelength light, detected by specialized cells in the retina. When this clock is well aligned with the external environment, mental performance follows a predictable arc, sharper in the mid-morning, a natural dip in early afternoon, and a gradual wind down toward evening. Your tiredness tonight is not random. It is orchestrated. The concept of cognitive load refers to the amount of mental effort being used in working memory at any given time. Working memory is limited. It can hold roughly 3 to 4 meaningful pieces of information simultaneously, depending on the complexity of what is being held. When cognitive load is high, the brain prioritizes processing current demands and reduces resources available for other functions. Over a long and complex day, sustained high cognitive load depletes this capacity progressively. By evening, what feels like an inability to concentrate is often working memory operating at its margin. Not broken, simply full, and gently asking to be emptied. Cortisol, often described as the body's primary stress hormone, follows a natural rhythm tied closely to sleep and waking. It peaks shortly after waking, a phenomenon known as the cortisol awakening response, helping the body mobilize energy and sharpen attention. Throughout the day, cortisol levels gradually decline. Chronic stress or extended mental effort can alter this natural rhythm, keeping cortisol elevated into the evening hours. Elevated evening cortisol interferes with the brain's transition towards sleep, delaying the release of melatonin and keeping the nervous system in a state of low-level alertness. Understanding this rhythm helps explain why winding down is not simply a matter of wanting to rest. The default mode network is a set of brain regions that becomes active when the mind is not focused on external tasks. During daydreaming, self-reflection, mind-wandering, and the kind of unfocused thinking that often happens just before sleep. For many years, this network was considered unimportant. More recent research suggests it plays a vital role in consolidating autobiographical memory, processing social and emotional information, and preparing the mind for creative insight. When you find your thoughts drifting tonight, meandering through memories and half-formed ideas, that is your default mode network. It is not idleness. It is one of the most real things your brain knows how to do. Attention is not a single faculty, but a collection of overlapping systems. Neuroscientists distinguish between sustained attention, the ability to maintain focus over time, selective attention, the ability to focus on one thing while filtering others, and executive attention, the ability to manage conflicting demands. Each of these systems has different neural bases and different patterns of fatigue. Sustained attention degrades most visibly with tiredness, which is why tasks that require long, unbroken focus become increasingly difficult as the day progresses. By contrast, brief engaging stimuli can temporarily restore alertness, even in a fatigued brain. The fact that you are still listening is a gentle form of that restoration. The relationship between mental exhaustion and the immune system is more direct than it might appear. Research has established that insufficient sleep and chronic mental fatigue alter the production and function of cytokines, signaling proteins that coordinate the immune response. Some cytokines, particularly those associated with inflammation, increase under sleep deprivation. Others, associated with antiviral and anti-tumor activity, decrease. This bidirectional relationship means that mental exhaustion weakens immune defenses, and conversely, that illness often announces itself first as profound tiredness. The exhausted mind and the stressed body are not separate experiences. They are the same system, communicating the same need. Microsleeps are brief, involuntary episodes of sleep that can last from a fraction of a second to about 30 seconds. They occur most commonly in people who are sleep-deprived or mentally exhausted, often without the person's awareness. During a microsleep, the brain temporarily disengages from the external environment. Sensory processing slows, and the person may have no memory of the gap. Microsleeps are the brain's attempt to restore equilibrium when exhaustion becomes too great to sustain wakefulness. They are a signal, a quiet insistence from the mind that the need for rest has moved beyond preference into necessity. You may have already had one today without knowing. Mental exhaustion has a measurable effect on perception of time. Studies have shown that fatigued individuals tend to perceive the passage of time as slower during tasks and experience greater difficulty accurately estimating elapsed duration. The neural mechanisms underlying time perception, distributed across the basal ganglia, prefrontal cortex, and cerebellum, require consistent attentional resources to function accurately. When those resources are depleted by fatigue, time estimation becomes imprecise. This is why the final hours of an exhausting day can feel interminable. While rest, by contrast, seems to pass gently and quickly. Tonight, let time dissolve around you. Creativity and mental exhaustion have a complex and somewhat counterintuitive relationship. Research suggests that moderately fatigued minds, not severely sleep-deprived, but gently tired, may show enhanced performance on certain types of creative thinking, particularly tasks that benefit from loosened associative thinking. The focused, inhibitory functions of the prefrontal cortex relax under mild fatigue, allowing more distant and unusual connections between ideas to surface. This is part of why insights sometimes come in the half-awake state before sleep. The relaxing of mental control is not a loss. In certain conditions, it is an opening. The brain's white matter, the vast network of insulated nerve fibers that carry signals between different regions, is sensitive to the cumulative effects of chronic sleep deprivation and mental fatigue. Neuroimaging studies have found subtle changes in white matter pathways in individuals with long-term sleep disorders, particularly in connections between the prefrontal cortex and deeper emotional and memory regions. These changes are associated with reduced processing speed and emotional regulation. The encouraging finding is that recovery sleep appears to support restoration of these pathways. The brain's architecture is not written in stone. Given rest, it quietly rewrites itself. One of the most consistent findings in sleep research is that subjective perception of tiredness diverges from objective performance under sleep deprivation. People who are chronically sleep deprived often report feeling only mildly tired, while their cognitive performance, measured by reaction time, working memory, and decision quality, shows real impairment. The brain, in its exhausted state, becomes less accurate at assessing its own condition. This is not self-deception. It is a neurological consequence of fatigue, affecting the very systems responsible for self-monitoring. The exhausted mind has difficulty knowing how exhausted it truly is. Rest, offered gently and without judgment, is always worth more than the mind believes it needs. Sleep architecture refers to the organized pattern of sleep stages that cycle through the night, each serving distinct biological functions. A typical night consists of 4 to 6 sleep cycles, each lasting approximately 90 minutes. Within each cycle, the brain passes through lighter, non-REM stages, deeper slow-wave sleep, and REM sleep. Slow-wave sleep is when the glymphatic system is most active, clearing cellular waste and consolidating declarative memories. REM sleep, characterized by rapid eye movements and vivid dreaming, is when emotional memories are processed and creative connections are formed. The brain tonight is preparing to conduct this cycle. Each stage is already waiting for you. The locus coeruleus is a small but vital structure deep in the brainstem, serving as the brain's primary source of norepinephrine, a neurotransmitter central to alertness, attention, and the stress response. During waking hours, the locus coeruleus fires regularly, maintaining a baseline of arousal. During sleep, it becomes nearly silent, allowing the brain to transition through its restoration cycles. Research has highlighted the locus coeruleus as particularly vulnerable to the effects of chronic stress and sleep deprivation. When it does not receive adequate rest, it can become dysregulated, contributing to persistent low-level anxiety and difficulty concentrating. Its silence tonight is not emptiness. It is the sound of healing. Rumination, the repeated, involuntary replaying of worrying thoughts, is one of the most common barriers to sleep in exhausted individuals. Neuroscientific research has linked ruminative thinking to elevated activity in the default mode network and reduced activity in the lateral prefrontal cortex, the region responsible for redirecting attention. Rumination is not a character flaw. It is a neural pattern, one that tends to activate most powerfully in conditions of fatigue, uncertainty, and unresolved stress. The mind returns to unfinished business because it is trying to resolve it, gently allowing those thoughts to drift, as you are doing now, is a skill, a kindness to yourself, and a form of neurological wisdom. Interoception, the brain's awareness of internal body states, including heartbeat, breath, temperature, and hunger, plays an underappreciated role in mental fatigue. The insula, a region of the cortex folded deep within the brain, is the primary hub for interoceptive processing. When we are mentally exhausted, interoceptive accuracy can decline. We become less precisely aware of what our body is signaling. This is part of why fatigued people sometimes forget to eat, overlook physical discomfort, or fail to notice escalating tension until it becomes notable. Gentle attention to the body, the weight of the limbs, the rhythm of breath is one of the most direct pathways back to calm. The relationship between mental exhaustion and language is quietly telling. Word retrieval, the ability to find the right word quickly, is one of the earliest cognitive functions to degrade under fatigue. The tip of the tongue phenomenon, where a word feels just out of reach, occurs more frequently in tired minds. This is because language retrieval relies on rapid, coordinated activation across multiple cortical networks, a process requiring precise timing that fatigue disrupts. When conversation becomes effortful late in the evening, when sentences feel harder to complete, that is the brain offering a clear and gentle signal. It has said enough for today. It is ready to rest in silence. Let's pause here and notice your body. As you breathe out slowly, turn your attention inward. Not to solve anything, simply to notice. Your brain right now is not demanding anything of you. The emotional weight of the day is beginning to soften at the edges. Neural circuits that fired relentlessly since morning are starting to quiet. On a B1. In the dark, notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, self-balancing, self-tending, and tonight, beginning to heal. Take one more slow breath, and now we continue. Theta brainwaves, oscillating at frequencies between 4 and 8 cycles per second, are associated with the hypnagogic state, the transitional zone between wakefulness and sleep. In this state, which many people experience as a dreamy, slightly disoriented feeling, the brain begins producing vivid imagery, fleeting insights, and sensory impressions disconnected from the external world. Many scientists, artists, and thinkers throughout history have described receiving their most notable ideas in this threshold state. Thomas Edison reportedly held steel balls in his hands while napping. As he drifted off, the balls would drop, waking him just as the theta state peaked. The exhausted mind, right at this edge, is among the most quietly creative states the brain can enter. The vagus nerve, the longest cranial nerve in the body, running from the brainstem through the chest and abdomen, plays a central role in the relationship between mental exhaustion and physical recovery. It is the primary conduit of the parasympathetic nervous system, which governs rest, digestion, and repair. When we are stressed or mentally fatigued, the sympathetic nervous system tends to dominate, activating the vagus nerve through slow, deep breathing, particularly with extended exhalations, helps shift the nervous system toward parasympathetic dominance. Each slow breath you are taking right now is not merely relaxing. It is physiologically restorative. It is science in motion. Sleep inertia refers to the grogginess, disorientation, and cognitive impairment that often follows waking, particularly from deep, slow-wave sleep. It can last anywhere from a few minutes to over an hour. In some individuals, during which reaction time, decision-making, and memory retrieval are measurably impaired. Sleep inertia is more pronounced when a person wakes from a deeper stage of sleep, when they are sleep-deprived, and when waking is abrupt rather than gradual. Understanding sleep inertia helps explain why the transition from sleep to full wakefulness requires time and gentleness, not only as a comfort, but as a biological reality. The brain, when it surfaces from deep restoration, needs a moment to remember where it is. Mental exhaustion affects decision-making in measurable ways. Research in cognitive neuroscience has shown that fatigued individuals are more likely to rely on intuitive rather than deliberative reasoning, and to make decisions with less careful consideration of longer-term consequences. This is not a moral failing. It is a cognitive resource problem. The neural processes involved in careful deliberation, particularly those mediated by the prefrontal cortex, are among the most energy-intensive in the brain. When mental resources are depleted, the brain conserves energy by defaulting to simpler processing pathways. The exhausted mind is not less capable of goodness. It is simply running on reduced reserves. The brain's reward system, centered on the nucleus accumbens and driven by the neurotransmitter dopamine, is meaningfully altered by sleep deprivation and mental fatigue. Under conditions of exhaustion, the reward system becomes more reactive to short-term rewards, while simultaneously becoming less responsive to longer-term goals. This neurological shift helps explain why tired people are more likely to reach for comfort food, defer important tasks, and seek immediate pleasures over effortful but meaningful pursuits. Recognizing this as biology rather than weakness changes the conversation entirely. The exhausted mind is not failing at willpower. It is compensating rationally with the resources it has. Proprioception, the brain's continuous sense of where the body is in space, becomes slightly degraded under conditions of notable fatigue. The neural signals from muscles, joints, and the vestibular system still reach the brain, but integration of those signals becomes less precise. This is part of why severely tired people can feel slightly unsteady, misjudge distances, or move less gracefully. It is also part of why the body, lying still in the dark, can begin to feel pleasantly weightless or slightly disconnected as exhaustion deepens. That sensation of dissolving into your bed is not imaginary. It is a gentle loosening of the maps the brain maintains of its own position. The hippocampus, a seahorse-shaped structure in the medial temporal lobe, is the brain region most critical for forming new memories. It is also among the most sensitive to the effects of cortisol and chronic stress. Prolonged elevation of cortisol, such as occurs during periods of sustained mental overload, can temporarily reduce hippocampal neurogenesis, the process by which new neurons are formed. Adequate sleep, by contrast, is one of the most reliable stimulants of hippocampal neurogenesis known. The brain, given rest, does not merely maintain itself. In certain conditions, it grows. Tonight is one of those conditions. Attention restoration theory, developed by environmental psychologists Rachel and Stephen Kaplan, and supported by ongoing neuroscientific research, proposes that directed attention, the focused, effortful kind required for most of daily life, has a finite capacity that is depleted through use and restored through restorative environments, natural settings. forests, water, open sky are particularly effective at restoring directed attention because they engage what the Kaplans called involuntary attention gentle, effortless, noticing that does not draw on depleted reserves. The calm imagery in these words, the slow rhythm of the narration, is designed to offer something similar, effortless engagement that asks nothing of your tired mind. There is a recognizable experience that many people know well, the sense that self-regulation becomes harder after prolonged effort. Whether this reflects changes in neural chemistry, motivational shifts, or something else entirely remains an active area of research. What is broadly observed is that sustained periods of effortful self-control, managing emotions, suppressing impulses, maintaining focus, create real changes in subsequent behavior and performance. The day asks so much of us. Tonight asks nothing. You are here simply to receive. Neuroplasticity, the brain's capacity to reorganize its structure, function, and connections in response to experience, is most active during sleep. The processes of synaptic pruning, where weak connections are eliminated, and long-term potentiation, where meaningful connections are strengthened, depend heavily on the quality and completeness of sleep cycles. Recent research has suggested that the sleeping brain does not simply preserve the day's learning, it selectively refines it, discarding what is redundant and reinforcing what is valuable. The exhausted mind that falls asleep tonight will not wake up exactly as it is. In ways invisible and precise, it will wake up slightly reorganized, slightly more itself. Emotional memory is processed differently from factual memory. The amygdala, working in concert with the hippocampus during REM sleep, reactivates emotionally meaningful memories in a neurochemical environment, notably different from waking. Specifically, one with reduced levels of norepinephrine, the stress neurotransmitter. This neurochemical context allows emotional memories to be revisited without the full physiological weight of their original intensity. Sleep. In this understanding drawn from decades of neuroscience research, acts as a kind of overnight emotional recalibration. Gentle, automatics, and available to you every night you choose to rest. You do not need to consciously process the difficult moments of your day. Your sleeping brain will do that work for you. The somatosensory cortex maps the entire surface of the body and continuously updates its representation based on incoming signals. As you relax and become still, the incoming signals from your skin, joints, and muscles decrease. The somatosensory cortex, receiving less input, grows quieter. This quieting, which can produce the sensation of the body's boundaries becoming less defined, of the edges of the self becoming soft, is a normal and healthy neurological process. Some traditions of meditation and contemplative practice have described this sensation for thousands of years. Neuroscience now describes the same phenomenon with different language. Both descriptions point toward the same experience of dissolving ease. Research has explored the concept of allostatic load, the cumulative wear on the brain and body, resulting from chronic stress and insufficient recovery. Unlike acute stress, which the nervous system handles effectively, allostatic load accumulates gradually and often without clear awareness. It is expressed in subtle ways: reduced cognitive flexibility, lower emotional tolerance, greater vulnerability to illness, a persistent, low-grade sense of tiredness that a single night of sleep does not fully resolve. Understanding allostatic load as a real biological phenomenon, not weakness, not complaint, opens the door to taking recovery not as a luxury, but as maintenance. Tonight is maintenance. The thalamus serves as the brain's central relay station, routing sensory information to the appropriate cortical regions for processing. As the brain transitions towards sleep, the thalamus plays a critical role in gating, gradually reducing the flow of sensory information to the cortex. This thalamic gating is what creates the sensation of the world becoming quieter and more distant as sleep approaches. Sounds that registered sharply an hour ago now feel muted. Further away, the edges of perception soften. This is not the world becoming less real. It is your brain, very deliberately, drawing the curtains. The concept of mental load, distinct from cognitive load, refers to the invisible labor of tracking, planning, and coordinating the responsibilities of daily life. Mental load is often sustained continuously, even during periods that feel like rest, reviewing tomorrow's tasks while watching television, composing emails in imagination while cooking, rehearsing conversations that have not yet happened. Research in occupational psychology has shown that persistent mental load meaningfully elevates fatigue, independent of physical or cognitive work. The mind that never fully stops planning is a mind that never fully rests. Tonight, there is nothing to plan. Whatever needs to happen tomorrow is already waiting. For now, there is only this. You're still here, still listening, still drifting with us through these quiet corridors of mind science. Just notice where your body is. Feel the weight of it, the warmth. We're exploring consciousness together. You and everyone else listening in the quiet, dark right now. There's no destination, no test at the end. Just the gentle unfolding of one fact at a time, carrying you slowly forward. Let's continue. Sleep spindles are brief bursts of oscillatory brain activity that appear during the lighter stages of non-REM sleep, identifiable on electroencephalograms as sudden, rhythmic peaks lasting about half a second to 2 seconds. They are generated by circuits between the thalamus and the cortex. Sleep spindles are associated with memory consolidation, particularly for procedural and factual information, and with resistance to being woken by external noise. Research has found that individuals who generate more sleep spindles during a given night tend to show better memory retention the following morning. For the exhausted brain, these quiet electrical signatures are evidence that even light sleep is doing real work. The relationship between light and mental exhaustion extends well beyond simple tiredness. Specialized photoreceptive cells in the retina contain a photopigment called melanopsin that is particularly sensitive to short-wavelength blue light. These cells send signals directly to the brain's master circadian clock, suppressing melatonin production and maintaining wakefulness. As natural light fades in the evening, this suppression lifts, and melatonin rises. One of the body's clearest communications to the exhausted mind that the day is releasing its hold. The dim, warm light of your room right now is already participating in your body's transition. The darkness is not absence. For a tired brain, it is permission. The phenomenon of second wind, the brief recovery of mental energy that sometimes occurs in the late evening, is a circadian artifact. It corresponds to a secondary alerting response driven by the body's internal clock, which can temporarily override the accumulating pressure of exhaustion. For many people, pushing through this second wind and choosing rest instead deepens sleep quality when they do finally lie down. The body has a schedule older than any habit. Honoring it, even when the mind briefly protests, is a form of listening to the oldest intelligence the nervous system carries. Chronic mental exhaustion is real, measurable, and distinct from the ordinary tiredness of a single demanding day. It builds gradually, often without clear awareness, until it touches everything. Attention, la patience, creativity, the ease of simply being present. It is not a failure. It is the shadow of sustained effort, the biological evidence of a mind that has been genuinely engaged. The path out is not effort in a different direction. The path out is rest. Tonight, you have already taken the first step. Exhaustion responds to rest, and rest begins precisely here. The brain's sensitivity to pain increases measurably under conditions of sleep deprivation and mental exhaustion. Research has demonstrated that sleep-deprived individuals show lower pain thresholds, meaning they perceive the same stimulus as more uncomfortable than well-rested counterparts. The neural mechanism involves altered function in the somatosensory cortex and the brain's endogenous pain modulation systems, including reduced activity in opioid and serotonin pathways. This is why the world can feel literally more uncomfortable when we are exhausted, not just emotionally, but physically. Rest is analgesic. Sleep is, among its many roles, one of the body's most effective and accessible ways of easing discomfort. Emotional contagion. The tendency to unconsciously absorb and mirror the emotional states of those around us becomes more pronounced under conditions of mental fatigue. The brain's emotional resonance circuits continue to function even when cognitive resources are depleted, but the prefrontal mechanisms that allow us to modulate absorbed emotions become less active. This means the exhausted mind is simultaneously more emotionally porous and less able to process what it absorbs. It takes on more and holds it less skillfully. This is not sensitivity as weakness. It is the nervous system, stretched thin, still trying to connect. Rest restores the boundaries. The cerebellum, long associated primarily with motor coordination and balance, has been increasingly recognized as playing a role in cognitive and emotional processing. It receives inputs from cortical regions involved in attention, language, and emotional regulation, and contributes to the timing and coordination of cognitive processes. Research suggests the cerebellum may be involved in the automatization of skills, the transfer of effortful, conscious processing into smooth, unconscious execution. When we are mentally exhausted, this automatization can break down temporarily, making familiar tasks feel oddly effortful. The tiredness is reaching into processes that should be effortless. It is the deepest signal yet that rest is needed. Mindfulness, the practice of attending to present experience with gentle, non-judgmental awareness, has been shown in multiple studies to reduce the subjective experience of mental fatigue, even in the absence of additional sleep. Neuroimaging research suggests that mindfulness practice reduces default mode network activity, particularly the ruminative, self-referential thinking that consumes meaningful mental energy, while simultaneously increasing activity in regions associated with present moment awareness. Even brief periods of mindful attention, such as the quiet noticing you are practicing right now, have measurable effects on neural activity. You are not simply resting, you are actively, gently, restoring N-acetylaspartate, or NAA, is a neurochemical marker of neuronal health and metabolic activity, measurable through magnetic resonance spectroscopy. Studies have found that NAA levels in certain brain regions, particularly the prefrontal cortex and hippocampus, decrease following periods of sleep deprivation and increase following recovery sleep. This provides a chemical signature of the restoration that sleep provides at the cellular level. Its fluctuation with sleep and recovery offers one of the most direct demonstrations available that the brain is not merely metaphorically in need of rest. It is an organ with genuine, measurable needs that only rest can meet. Halfway through our journey tonight, something worth noticing: the facts have been growing simpler, their sentences shorter, their imagery softer. That is not accidental. It mirrors what your brain is doing right now, moving from the rapid, detailed processing of early evening toward the slower, more diffuse awareness of deep relaxation. Science and sleep share a rhythm. The mind that began this journey alert and precise is the same mind that is now, incrementally, allowing complexity to soften into stillness. Every fact has been a step. Every breath has been a step. The exhausted mind, given permission and gentleness, does not need to fight its way to rest. It only needs to stop resisting the direction it was already moving. Let each breath guide you to realize time is yours tonight. Every cell in your body is moving through its own slow cycle of renewal. Neurons are quieting. Muscles are releasing. The chemistry of your tiredness is beginning to transform into the chemistry of restoration. Each moment you spend here is not time passing. It is time being used perfectly. For the one thing the body has always needed most, your mind has been everywhere today. Right now, it is only here, and we continue drifting. The sleeping brain is not uniform in its silence. Different regions fall into different depths of sleep at different rates, a phenomenon called local sleep. Researchers have observed that after periods of intense cognitive use, the brain regions most heavily recruited during those activities show deeper local slow waves during subsequent sleep, as if those specific neural circuits are resting more deeply to recover more fully. The exhausted prefrontal cortex does not just receive the same sleep as the rest of the brain. It may receive more. There is a quiet justice in that. The glymphatic system, which clears metabolic waste from brain tissue during sleep, has been studied in relation to sleeping position. Animal model research found that lateral positions enhanced glymphatic fluid movement compared to other positions. And more recent human research has begun to explore whether this holds true in people as well. The evidence is still unfolding. What matters most is not the exact angle at which you rest, but the depth and completeness of sleep itself. Position is a detail. Rest is what opens the door, and the door is already opening. The neurotransmitter serotonin plays multiple roles in the regulation of mood, cognition, and the sleep-wake cycle. During waking hours, serotonin levels support positive mood and cognitive clarity. As sleep approaches, serotonin is converted in the pineal gland into melatonin, the hormone directly responsible for signaling the body to sleep. This chemical transformation is one of the brain's most elegant processes. The very molecule that sustained your mood and engagement during the day becomes the molecule that guides you into rest. The energy of waking is not discarded at night. It is transformed into something softer. Working memory, the mental workspace that holds and manipulates information in real time, is among the cognitive systems most vulnerable to fatigue. Its already limited capacity shrinks further under sleep pressure, narrowing the window of what the mind can actively hold and work with. When an exhausted person struggles to follow a complex instruction or loses their train of thought mid-sentence, it is often working memory that has reached its edge. There is no shame in this. It is the most human of limitations. It is biology asking, in the gentlest possible way, for sleep. The process of falling asleep involves a gradual decoupling of consciousness from sensory input. As sleep pressure mounts and the thalamus begins its gating function, external sounds become muffled, light becomes less intrusive, and the mind's representation of its own body becomes softer and less precise. This decoupling is accompanied by a shift in brainwave activity from the fast, irregular rhythms of alert wakefulness to the slower, more synchronous waves of light sleep. The transition is usually gradual, often barely perceptible. Most people cannot identify the exact moment they cross the threshold. The mind simply loosens its grip on the world, and the world gently releases its hold in return. Social cognition, the ability to understand and navigate the mental states, emotions, and intentions of others, is impaired by sleep deprivation in ways that are real and meaningful. Fatigued individuals show reduced accuracy in reading facial expressions, particularly for subtle or ambiguous emotions. They are more likely to interpret neutral expressions as negative and more likely to misread social cues. This creates a tender paradox: the person most in need of support, the exhausted, overwhelmed individual, is simultaneously least equipped to perceive and reach for it. Rest does not only restore the individual, it restores the person in relationship with others. The exhausted brain does not only need silence, it needs something only deep rest can trigger. During the first cycle of slow-wave sleep, the pituitary gland releases its largest pulse of growth hormone for the entire day. This hormone supports tissue repair, to muscle maintenance, immune function, and metabolic regulation throughout the body. It is not only children who need this hormonal release for growth. In adults, it sustains the ongoing repair and maintenance of the body's systems. Sleep is not simply rest for the mind. It is the body's primary repair interval, and the brain orchestrates every moment of it. Research suggests that recovery from extended sleep deprivation may require multiple nights of unrestricted sleep, and that some subtle cognitive and physiological effects persist beyond what subjective experience captures. The concept of sleep debt points to something real. Insufficient sleep over multiple nights accumulates in the body and brain in ways that a single night cannot fully resolve. A single good night matters enormously, and it is also the beginning of something larger. Each night you choose rest is a contribution toward what the body has been quietly carrying. Tonight counts. It always has. The anterior cingulate cortex sits at the intersection of cognitive and emotional processing. It is involved in error detection, conflict monitoring, and the regulation of attention toward motivationally meaningful stimuli. Under conditions of fatigue, its activity decreases, and with it, the brain's capacity to notice its own errors and adjust course. This is why exhausted people often persist with the same approach, even when it is not working. Rather than flexibly adapting, the monitoring system that would prompt change is too tired to insist. Recognizing this is not self-criticism. It is self-knowledge. The exhausted mind has been doing its best with what remained. The science of local sleep has revealed that the brain can enter sleep in isolated patches even during apparent wakefulness. Some neurons may be in a sleep state, while others remain awake, creating a mixed condition of partial awareness. This phenomenon challenges the simple binary of awake and asleep. The brain does not flip a single switch at the end of the day. It dims, gradually, in stages, region by region, until the whole system has surrendered to restoration. You may already be dimming now. That is not a failure of alertness. It is the most natural thing in the world. The heart rate naturally slows during the transition from wakefulness to sleep. As the parasympathetic nervous system gains dominance, the heart's natural pacemaker receives fewer accelerating signals and more slowing ones. Blood pressure drops, breath deepens and slows, and the cardiovascular system enters its own restorative mode. This is why the resting heart rate during sleep is typically the lowest of any period in the 24-hour cycle. The heart, like the mind, has been working since morning. In the quiet of this moment, it is already beginning to find its slowest, most sustainable rhythm. The experience of exhaustion carries individual and cultural variation that science is only beginning to understand. Different people report different patterns of fatigue: cognitive, emotional, physical, and different thresholds for when tiredness becomes impairing. Language shapes the experience as well. Different languages have different granularity for describing states of tiredness, which may influence how the experience is processed and communicated. What is universal is the underlying biology, the adenosine, the cortisol, the glymphatic need. Beneath every expression of tiredness is the same brain, with the same ancient need, asking for the same ancient restoration. The precuneus, a region of the parietal lobe involved in self-reflection, visuospatial processing, and the retrieval of personal memory, shows particularly high activity during the default mode. Networks activation and reduced activity during deep sleep. Some researchers consider it a key node in conscious awareness. Its quieting during sleep is associated with the loss of self-referential experience, the cessation of the internal monologue, the autobiographical narrative, the persistent sense of being a self with history and obligation. When the precuneus grows quiet, the story of today pauses. There is only the breath. There is only the dark. Proprioceptive feedback from the muscles and joints decreases as muscle tone drops during the early stages of sleep. In REM sleep, this goes further. Active muscle paralysis, called atonia, is produced by the brainstem to prevent the physical enactment of dream movements. This paralysis is a protection, a boundary between the inner world of dreams and the outer world of the body. It occasionally surfaces at sleep onset as the hypnic jerk, the brief, involuntary muscle contraction many people experience as they are falling asleep. If you feel this tonight, let it pass. It is simply the body releasing the last of its readiness. It is the muscles finally letting go. By this point in our journey, something measurable has likely shifted in you. Your breathing has slowed. The muscles around your eyes have softened. The thoughts that were following the facts at the beginning may now be arriving more loosely, in fragments, sometimes not arriving at all. This is the exhausted brain moving, fact by quiet fact, toward its threshold. The tiredness you carried through the door tonight is not a problem to be solved. It is a signal that has been heard, and what comes next? The cleaning, the sorting, the repair is already underway. Temperature regulation is an active process during sleep that reflects the brain's effort to create optimal conditions for restorative processes. Core body temperature naturally falls by approximately 1 to 2 degrees Fahrenheit during the first hours of sleep, a drop that facilitates the transition into deep, slow-wave sleep. The brain orchestrates this cooling through the hypothalamus, increasing heat dissipation from the skin of the hands and feet. A cool room, around 65 to 68 degrees Fahrenheit, supports this natural cooling. If your room is cool tonight, your body is grateful. If it is warm, it will find its way. The default mode network, active during rest periods and mind wandering, plays a role not only in reflection and creativity, but also in prospective memory, the ability to remember to do things in the future. Its activation during quiet moments may serve a function of mental rehearsal and forward preparation that is distinct from and complementary to focused work. The mind that wanders during these moments before sleep is not wasting time. It is, in ways not yet fully understood, preparing for tomorrow. And when the wandering stops and becomes stillness, the preparation is complete. Research on the neuroscience of self-compassion, the ability to treat oneself with the same kindness one would offer a friend in difficulty, has found it associated with greater psychological resilience, lower rates of chronic exhaustion, and better sleep quality. Self-compassion activates the caregiving systems of the brain while reducing activity in self-critical circuits. The exhausted mind that lies here tonight, perhaps carrying a weight of what went undone, what was said imperfectly, what remains unresolved. That mind deserves the same tenderness it might offer anyone else. It did what it could. That is enough. The brain's response to novel stimuli, the orienting reflex, is mediated primarily by the reticular activating system, a network of nuclei in the brainstem, responsible for regulating wakefulness and arousal. Familiar, predictable, gently repetitive stimuli, like a calm, consistent voice or steady ambient sound, gradually reduce reticular activating system firing, allowing arousal to decrease. This is part of the science behind lullabies, white noise machines, and podcasts designed for sleep. The familiar is calming not only emotionally but neurologically. Predictability is safety, and safety is the doorway through which sleep most easily arrives. The thalamocortical loops that generate sleep spindles also appear to play a protective role during sleep, gating out ambient sounds and preventing them from reaching the cortex with enough force to trigger waking. This spindle-mediated noise gating is one reason some people can sleep through considerable environmental sound once they have entered light sleep. The strength of this protection varies between individuals and tends to be greater in people who generate more sleep spindles. The brain, in its lighter sleep, is actively standing watch so that deeper sleep can arrive safely. It is guarding you even as it rests. Acetylcholine, a neurotransmitter released in high levels during REM sleep, plays a central role in the vividness and narrative coherence of dreams. It also contributes to the learning and memory processes associated with REM sleep. During wakefulness, acetylcholine levels are also high, supporting attention and memory encoding. During non-REM sleep, acetylcholine levels drop, allowing the consolidation processes of slow-wave sleep to proceed. The chemistry of dreaming and the chemistry of learning share the same molecule. The mind that is curious during the day and dreaming at night is drawing on the same ancient, essential compound. Research into the neural basis of insight has consistently found that sleep, and the REM stage in particular, enhances the likelihood of finding elegant, non-obvious solutions to problems. The sleeping brain, freed from the focused constraints of directed attention, explores associative pathways that waking cognition rarely traverses. The exhausted mind that could not find the answer today may encounter it on the other side of tonight. Not because it worked harder, but because it finally stopped. The answer you could not reach through effort may arrive as a gift from sleep. The brain's descending pain inhibition systems, which include pathways through the periaqueductal gray matter in the midbrain, are more active during sleep, contributing to reduced pain sensitivity in deep rest. For individuals with chronic pain, sleep disruption creates a reinforcing cycle. Pain disrupts sleep, and disrupted sleep lowers the pain threshold, intensifying the experience. Breaking this cycle through sleep support is one of the most meaningful applications of sleep medicine. Rest changes the pain equation, quietly and without effort from you. You only need to allow it. The sense of self is not a fixed structure, but an active construction, continuously assembled by circuits across multiple cortical regions. When we are awake and engaged, the self is maintained with relative consistency. As sleep approaches, this construction requires more resources to sustain and gradually loses coherence. The boundaries of the self soften. The certainty of individual identity becomes less pressing, less defended. This is not loss. It is a natural and recurring dissolution. The self taking its daily rest from the effort of being every morning, and it reassemble, slightly revised. By fact 75, the arc of this journey has brought us from the precise chemistry of adenosine and prefrontal metabolites, through the emotional vulnerabilities of the tired brain, through the restorative machinery of sleep and repair. The exhausted mind is not a broken mind. It is a mind that has been used fully, honestly, humanly. The science does not end at the edge of sleep. It continues in the dark, but your need to follow it with full attention can rest here. The most important fact remaining is simply this: you are safe. The science is taking care of the rest. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your heart has beaten without interruption since before you can remember. Your lungs have breathed without instruction. Your brain has sorted and adjusted and guided you through the entire day, without ever asking for acknowledgement. These cycles do not stop when you sleep. They deepen. You don't need to hold on to any of this. Let everything unfold in its perfect order, like a mind that has finally stopped asking what comes next, and simply arrives in the present. We're almost there now. The brain's transition into deep sleep is accompanied by the appearance of K complexes, large, sharp waveforms that appear suddenly against the slower background activity of stage 2 sleep. K complexes may serve to suppress cortical arousal in response to stimuli that do not require a full waking response. They are among the largest electrical events the brain produces. The sleeping brain is not passive. It is attentive, filtering, protecting. It knows what to let through and what to quiet. During REM sleep, the brain shows patterns of activity resembling wakefulness in many regions. Yet the body is almost completely still. The exhausted mind, finally given permission to dream, becomes as active as the waking mind, perhaps more so in certain emotional and creative dimensions. What sleep takes from the body, it gives back to the inner world. The stillness outside is only the surface. Beneath it, something vast is moving. The exhaustion you felt today begins its chemical reversal in the dark. Melatonin, secreted by the pineal gland in darkness, does more than signal sleep. It is a potent antioxidant, protecting neural tissue from the oxidative byproducts of metabolic activity that accumulated throughout the day. The darkness you are resting in right now is not merely the absence of light. It is an environment in which your brain is being gently protected, cell by cell, from the traces that effort leaves behind. The hippocampus and neocortex engage in a quiet dialogue during sleep, a coordinated exchange in which memories held temporarily in the hippocampus are gradually transferred to more permanent storage in the cortex. This dialogue happens in the slow rhythms of sleep. It cannot be rushed. It requires the quiet that you are giving it right now. Research has found that even a single night of good sleep, following a period of stress, measurably reduces activity in the amygdala the following day. The emotional weight of yesterday is not carried unchanged into tomorrow. Sleep does something to it. Something gentle. Something chemical. Something real. The difficulty you felt today will be lighter tomorrow. That is not hope. That is neuroscience. The night, allowed to complete itself, has gifts in its later hours. The REM periods that contain the most vivid dreaming grow longer across the night. The cycles in the early morning hours carry the most emotionally restorative content. The exhausted mind that surrenders to a full night of sleep receives something different from one that is cut short. Stay. Let the night finish its work. The brain's use of energy during sleep does not fall dramatically. It remains metabolically engaged throughout the night. What changes is how that energy is spent. The high-cost processes of directed attention and self-regulation give way to the quieter but equally real processes of maintenance, consolidation, and repair. The exhausted brain is not switching off. It is redirecting everything it has toward becoming whole again. As exhaustion peaks and the day releases its hold, a small shift happens in the brain's chemistry. Orexin, a neuropeptide that promotes wakefulness and resists the pull towards sleep, gradually quiets in the evening hours. This chemical standing down is one of the final steps in the brain's preparation for rest. The wakefulness-promoting system does not fight sleep forever. At some point, it simply lets go. Something in the chemistry of night is on your side. It always has been. The tired body has one more gift for you as the night deepens. Core body temperature continues its slow descent during the early hours of sleep, reaching its lowest point approximately 4 to 5 hours after sleep onset. This thermal low point corresponds with the deepest hormonal restoration of the night. The night has a shape, a descent, a depth, and from that depth, a slow and patient return toward morning. Brain-derived neurotrophic factor, or BDNF, is a protein that supports the survival and growth of neurons and promotes the formation of new synaptic connections. Its expression is enhanced by sleep, particularly during the slow-wave stages. BDNF is one of the molecules that links rest tonight to learning, emotional resilience, and long-term brain health. The exhausted brain, given rest, is not simply maintaining itself in very small, very real ways. It is growing. The quieting of the locus coeruleus during sleep, the small structure whose norepinephrine has been fueling your alertness and stress responses all day, is one of the most profound shifts in the sleeping brain. Without its continuous arousing signal, the cortex settles into its slower rhythms. The anxiety that fatigue amplifies subsides. The night is, chemically, the quietest the alarm system will be in the entire day. Rest here. This is the stillest it will sound. Memory reconsolidation. The process by which retrieved memories become temporarily malleable and are then restored in a potentially altered form, suggests that our relationship with the past is never entirely fixed. Each time a memory is recalled and then slept upon, it has the opportunity to be gently rewritten, not erased, not falsified, but integrated, placed into a slightly different context, held with a slightly different emotional weight. Sleep gives the past the gentlest of editors. The exhausted mind, when it finally releases the day, begins to create. During REM sleep, the visual cortex, auditory cortex, and motor regions all activate, generating the vivid experiences of dreaming without any input from the external world. Characters appear, places emerge, all of it from within. The dreaming mind is not escaping reality. It is demonstrating the brain's most extraordinary capacity to generate experience from pure neural activity. You carry an entire world-building system behind your closed eyes. Scientific understanding of consciousness remains one of the deepest open questions in all of science. What we know is that sleep profoundly alters whatever consciousness is, dimming it, transforming it, occasionally producing the vivid semi-consciousness of dreaming. The boundary between awareness and non-awareness is not a wall, it is a gradual, shifting horizon. Right now, you are somewhere near that horizon, moving gently toward it. Research has explored how sleep benefits emotional granularity, the ability to distinguish between and accurately name specific emotional states. Well-rested individuals tend to show finer emotional discrimination, identifying their feelings with greater precision and nuance. Fatigued individuals tend toward more global, undifferentiated responses. Things feel simply bad or good, heavy or light. Sleep restores the vocabulary of the inner life. Tomorrow, you may find words for things that tonight only feel like weight. The autonomic nervous system undergoes regular calibration during sleep. The alternating dominance of sympathetic and parasympathetic activity across sleep cycles provides the body with a daily reset, maintaining the balance and responsiveness of the systems that govern heart rate, digestion, breathing, and more. This calibration contributes to cardiovascular health, immune function, and the body's readiness for tomorrow. Every night is a tuning, a quiet recalibration of everything that keeps you running. Neuroscientists have found that the sleeping brain shows patterns of coordinated activity across distant regions that are rarely seen during wakefulness. Large-scale synchrony that may reflect the integration of information across the brain's separate networks. Some researchers have proposed that this overnight integration is what allows facts to become understanding, details to become patterns, experiences to become wisdom. Sleep does not only preserve what you have learned, it helps you understand what it means. The relationship between sleep and creativity has been documented across centuries. Writers, mathematicians, musicians, and scientists have described dreams, or the threshold state, before sleep, delivering solutions and insights that waking effort could not reach. The REM brain, with its unusual neurochemistry, high acetylcholine, low norepinephrine, generates associations between loosely related concepts with a freedom unavailable to the directed waking mind. What you are releasing tonight is not time. It is an invitation for a different kind of thinking to begin. The science of the exhausted mind leads, inevitably, to the science of the restored mind. Not because exhaustion is a problem to be solved, but because it is a message to be received. The brain does not tire arbitrarily. It tires in proportion to how fully it has been used. Exhaustion is the shadow of effort, the evidence of engagement, and every time it leads to rest, honest, willing rest, something is completed. A cycle closes. A need is met. Something that was open is gently allowed to close. The final facts of this journey arrive not as information but as permission. You have traveled through the chemistry of fatigue, the architecture of sleep, the vulnerability and resilience of the tired mind, and the profound biological intelligence of rest. You do not need to remember any of it. The science will continue without you. The glymphatic system will do its work. The hippocampus will do its sorting. The amygdala will soften its grip. All of it will happen. All of it is already beginning. You have nothing left to do tonight except allow it. And so, our quiet journey through the exhausted mind comes to a gentle close. We began with adenosine, building its quiet pressure in the spaces between neurons, the chemical signature of a mind that has truly been used. We traveled through the prefrontal cortex, dimming its brilliant, costly light, through the amygdala growing tender, more easily moved, through the glymphatic canals preparing their slow, thorough cleaning. We passed through the locus coeruleus, standing down, through serotonin, transforming into melatonin, through the hippocampus, beginning its careful correspondence with the sleeping cortex, from the busiest decision center in the known universe to the softest edge of conscious awareness. This mind, your mind, has been everywhere today. Mental exhaustion reminds us that thought is physical, that consciousness has a cost, that the invisible labor of attention, of caring, of keeping everything together, leaves real traces in real tissue. It shows us that the brain, for all its complexity, is also a body. It hungers, it aches, it heals. By pausing to notice, we glimpse the extraordinary in the ordinary, the profound biology hidden inside the simple feeling of being tired. You are not running on empty tonight. You are running toward fullness. In these final minutes, take the deepest breath you can, as deep as possible. Think about consciousness itself. Yours, mine, everyone listening, all awareness, everywhere. Perhaps all connected in ways we don't yet understand. Think about how every mind that has ever grown tired has also, eventually, rested. How every brain that has cleaned itself in the dark has woken with something renewed. You are not separate from that ancient cycle. You are part of it. Tonight, as you have always been, let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep. No boundaries left, only peace. If this thoughtful exploration of the exhausted mind helped you find rest or simply quiet tonight, a gentle like, subscribe, or share could help another tired soul discover this peaceful space too. It only takes a moment, but it means the world to us. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight. Not across distance, but through depth, through the most intimate geography there is, the mind that carries you through every moment of every day. You can allow these thoughts of the exhausted mind to fade now, like the last signal crossing a quieting synapse. Not gone, simply becoming something softer, leaving only the warm, dark calm behind. Let your breathing deepen. Let your body feel heavier, as if the gentle, patient weight of every hour you gave today is finally, simply, setting itself down. If sleep comes, let it carry you the way adenosine finally met by rest. Not forced, not rushed, but arriving exactly as it was always meant to, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the science will still be there. The brain will still be extraordinary. But tonight belongs to stillness. Rest well, sleepy soul. And remember, the mind that tires is the mind that cares. And the mind that rests is the mind that heals. Good night.